Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood. Today, we'll be learning all about chalk, and if you're looking for more fun facts for back to school, check the links in the show notes because I've done a lot of episodes that could work well in the classroom. Now, as always, before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. Generations of students and teachers have spent hours writing on blackboards with sticks of white chalk. A common assumption is that these classroom tools are carved straight from the earth, made of the same geological material found in natural chalk deposits like the White Cliffs of Dover. It seems logical that the product called chalk would contain actual chalk, right? What do you think? Is the chalk we use on a blackboard a natural material extracted from the ground like clay? We'll find out at the end of the episode. Now for your word of the day. Our word for today is coccolith. That's coccolith. Coccolith refers to the microscopic limestone plates that form the foundation of natural chalk. These tiny discs are produced by single-celled marine plants called coccolithophores that float in the upper layers of the ocean. These organisms make protective outer shells out of calcium and carbon that they extract from the seawater. When they die, the organic material decays and the solid calcite plates sink to the ocean floor. Over millions of years, the weight of the water compresses these accumulated layers of coccoliths into the solid white rock we recognize as chalk. The word coccolith was coined in 1858 by the English biologist Thomas Huxley. He was the first one to observe these structures under a microscope. He combined two Greek roots. The prefix kokkos translates to seed or a berry, referencing the round, granular shape of the microscopic structures, while the suffix lithos means stone or rock, a common root found in other terms like monolith or lithography. A time for your daily high five, our top 5 fun facts about chalk. Number 1. Natural chalk deposits helped scientists define an entire geological time period known as the Cretaceous period. In 1822, a Belgian geologist named Jean Dalmalius Dalloy noticed extensive matching bands of white rock stretching across Europe. He named this rock layer the terrain Cretaceous using the Latin word creta, which translates to chalk. This naming convention established the Cretaceous period, a span of time lasting from 145 million to 66 million years ago. During this period, high global sea levels flooded large portions of the continents with warm, shallow oceans, and these conditions provided the ideal environment for the microscopic algae that produced chalk to multiply in massive quantities. The accumulation of these organisms created some of the most recognizable geographical landmarks on the planet today. The White Cliffs of Dover in England and the similar cliffs in Normandy, France, formed during the Cretaceous period. As tectonic plates shifted and sea levels eventually fell, the thick layers of ocean sediment pushed upward to become dry land. Geologists used this distinct white rock layer as a reliable marker to date fossils found in the surrounding Earth. Dinosaur bones discovered just below these chalk deposits provide a timeline for animal life ending with the Cretaceous mass extinction. Number 2. The world's largest chalk drawing on pavement covered more than 200,000 square feet. On August 16, 2015, about 20,000 people got together to set a world record. They made an enormous chalk drawing in Copenhagen, Denmark, securing the Guinness World Record for the largest chalk pavement art. The organizers provided over 100,000 sticks of sidewalk chalk so they could cover every square inch of the space. And in the end, the artwork covered 200,183 square feet, basically doubling the previous record. The chalk drawing was organized by the local art association Solwash and the Danish artist Emil Clem, who provided some structure by sketching a massive guiding arrow down the center of Northbridge Street in Copenhagen. The artwork was a public event filling the street with vibrant chalk to spread positivity and foster community spirit. Temporary street closures allowed the participants to work safely without traffic, and the final design became an immense, colorful mosaic. Within the outline, people had complete creative freedom, resulting in a wide variety of individual drawings, text, symbols, and just free-form scribbles. Number 3. Farmers actually use pulverized chalk in their fields. The practice of adding crushed chalk to farmland, known as agricultural liming, dates back thousands of years, all the way to the Roman Empire. Soil often becomes overly acidic due to rainfall, plant growth, and repeated application of nitrogen-based fertilizers. High acid levels cause toxic elements like aluminum to dissolve into the groundwater, stunting root development in crops. The calcium carbonate in chalk acts as a base, neutralizing the acid and raising the pH level of the soil. This chemical reaction creates a balanced environment where essential nutrients like phosphorus become available for plant roots to absorb. Modern farms regularly test their soil to figure out the exact tonnage of chalk needed per acre. Tractors are equipped with spreader attachments to distribute powdered chalk evenly across the fields before planting season begins. And they have to do this while the weather is dry because wet chalk clumps together and clogs the machinery. Once it's mixed into the topsoil, though, the chalk breaks down slowly, providing chemical benefits for several growing seasons. Number 4. Tailors use a special form of chalk that disappears under the heat of an iron. Clothing manufacturers and tailors rely on tailor's chalk to mark fabric for cutting, hemming, and stitching adjustments. Traditional tailor's chalk is formulated from talc or a hard clay rather than calcium carbonate found in the geological chalk. These materials give a crisp, temporary line that resists smudging while the fabric is handled by people for cutting, folding, sewing, or whatever. To prevent permanent stains on expensive garments, chemists developed a vanishing chalk using wax compounds. The wax formula reacts to temperature changes, allowing the marks to disappear without washing or chemical treatments. When the tailor completes the alterations, they just press a hot iron over the marked fabric sections. The heat causes the wax-based chalk to sublimate, transitioning from a solid state into a gas. It dissipates into the air, leaving no residue on the threads of the clothing. This saves time in the production process and protects delicate fabrics like silk and wool from water damage. And our fifth and final fun fact for today. Before the invention of full-color chalk pastels, the greatest artists in the world created lifelike portraits using the only 3 colors of chalk they had available. During the Renaissance, artists like Leonardo da Vinci and later Peter Paul Rubens popularized a drawing method called a trois crayons, or the 3 chalks technique. Instead of the synthetic rainbow of chalks we had today, they had to find natural earth pigments mined from the ground. Black chalk was made from carbon-rich shale, white chalk from calcium carbonate, and red chalk, known as sanguine, was made from clay rich in iron oxide. But they made the most of every element, including not just the chalk, but also the paper. They would often use toned paper, like a mid-tone gray or tan, as the base skin color. That way, they could use the red chalk to add some warmth to the cheeks and the lips, and the black chalk to deepen the shadows for sharp details, while the white would capture just the brightest highlights. By letting the paper do most of the work and optically blending these three natural chalks, they were able to create a strong illusion of full, vibrant flesh tones using nothing but three colored rocks. And as long as I'm going down a little art history rabbit hole, here's a little bonus fact for today about an artist who worked a little bit later. Edgar Degas was a famous impressionist painter in the late 19th and early 20th centuries. Since he was working in the industrial age, he did have that full range of colors available to him, as chalk pastels were made with various synthetic pigments. But pastels are notoriously fragile. There's no wet binder to hold the chalk dust to the paper, so even just the slightest bump or a breeze can ruin a drawing. Degas hated how fragile his work was, so he worked with a close friend, a painter and chemist named Luigi Chialiva, to invent a new fixative using casein, water, and alcohol. While other artists lightly sprayed their drawings to protect them, Degas would soak his chalk layers in Chialiva's formula and sometimes expose the paper to steam. The heat and moisture effectively melted the chalk dust and the fixative together into a solid paste on the paper. Degas would apply this fixative between layers of chalk so he could build up the drawing without blending, giving the final work more depth and luminosity. Now for some news you can use. Many beginners struggle a bit when it comes to mixing colors with chalk. For example, if they're trying to mix like red and blue to make purple, they usually overdo it, rubbing the colors on top of each other too heavily. The result is almost always a dull, muddy gray, almost turning brown. Now, part of this is because you get a better purple by mixing pink and blue, but I don't want to get too deep into the weeds on subtractive color theory right now. The pro trick with chalk, though, is to use a bit more optical blending with techniques like cross-hatching. Instead of smudging all the chalks together, draw tiny alternating little dots and dashes of pinks, reds, and blues right next to each other, leaving a little bit of the paper showing through. When you step back, your eyes will do the mixing for you, creating the brilliant purple you want to see. Now, the obvious question is, why not just mix it all together? Basically, it's because chalk is made of opaque minerals. Physically rubbing the two colors together essentially crushes the pigment particles into a dense, chaotic layer. This uneven layer traps light, absorbing multiple wavelengths and reflecting a desaturated brownish-gray mess. By placing the pure colors side by side, you maintain their intensity. Because the dots are so small, the eyes can't resolve them individually from a distance, so your brain takes these adjacent signals and just averages them out, creating a vibrant secondary color in your mind. Finally, the moment you've been waiting for. At the beginning of the episode, I asked if the chalk we use to write and draw is the same material found in natural geological chalk deposits. Well, if you guessed that classroom chalk is made from natural calcium carbonate, you're right. But if you guessed that it's made from something else, you're also correct. It's a little bit of fact and fallacy. Here's the deal. Raw, natural chalk straight out of the earth is far too brittle and dusty for everyday writing and drawing. I mean, centuries ago, people did use raw chunks of natural chalk, but really throughout the 19th and 20th centuries, manufacturers came up with much cleaner and more sturdy mixes for chalk. Today's chalk is not really the raw rock, it's more of a processed material. Many traditional blackboard chalks and sidewalk chalks are made using gypsum, which isn't calcium carbonate, it's calcium sulfate. It's baked, ground into powder, mixed with water and binders, and then molded into sticks. But interestingly, although natural chalk is too brittle and dusty for people to use, many of the modern chalks advertised as dustless are actually made using calcium carbonate. The difference is, instead of being just dug straight out of a cliff face, the calcium carbonate is purified, pulverized, and then reformed with binding agents like clay or gum to create a smooth, durable stick of chalk. Now, I hope you enjoyed learning a bit about chalk with me today, and be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.